There is an interesting narrative about the midterm election of the U.S. Congress, that is somehow correlated with the presidential party. Over the past 100 years, the majority of the House of Representatives has swung back and forth between the two parties, Democratic and Republican. It is not obvious if the control of the House has any correlation with the presidential party. However, instead of looking at the party, if one looks at the midterm election change of the incumbent presidential party, then an interesting pattern emerges. First, consider the changes in the House of Representatives. Because the fixed number of seats, namely 435, the two-party gains and losses are symmetric. The gain of one party is the loss of the other. The data points are redundant because they mirror each other. However, instead of keeping the data of either party, Democratic or Republican, we keep the data, not by the party, but by the presidential party. In other words, if the president is Democratic, only the gain-loss data of the House Democrats are shown, those of House Republicans are removed. And vice versa. Then the data pattern becomes like this. Next, the red and blue lines are removed, and the data points are separated into two categories, gain-loss in the general election, and gain-loss in the midterm election. The two interesting patterns now emerge. For the general elections, the presidential party mostly gains seats. For the midterm elections, the opposite happens, the presidential party mostly lost seats. This pattern applies to both parties. In fact, only 3 times over the last 110 years, that is, 3 out of 28 midterm elections, in which the presidential party gained a very few modest seats. The gain in the general election can be called presidential coattail effect. Conversely, the subsequent loss in the midterm election can be considered a correction, like a stock market correction. The two effects are statistically quite significant. They are far beyond any possible random coincidence. Shown are the two histograms. The average midterm loss is 32 House seats, the average presidential coattail gain is 15 seats. Their means are distanced apart by more than the sum of their standard deviations. While the data are over 110 years, and each election is thought to be on its own, independent from each other, it is undeniable that there is a historical trend reflecting the voter behavior that, like culture, is consistent over a long period. This is the underlying rationale for the use of historical analysis. The large fluctuations in distanced past, however, are not typical for recent history. The Great Depression, and subsequent World War II, unquestionably, affected the U.S. politics like no other event since the Civil War. At the cost of less data, but to avoid historic episodes, the analysis can be restricted to the most recent 50 years or so. The midterm correction is still substantial. The incumbent party expected loss is 23 seats, although the presidential coattail is more modest at 5 seats. These statistics can be used as one factor, among others, for a projection. There are several factors that can be used for a historical data-based projection. What discussed above is the well-known midterm election voter swing trend, which is just one among others. For example, if one naively uses the midterm voter swing trend, the projection is that the Democratic Party will end up with 198 seats, and the Republican with 235 seats. However, the uncertainty of one standard of deviation is quite large, plus/minus 23 seats. A naive way to look at this is that there is 78% chance the opposing party, Republican in this case, to control the House of Representatives after midterm 2022. Another factor that can be considered is the balance of power between the two parties. In the above, we look at the long-term swinging of power between the two parties. The pendulum is often an apt analogy for the switching back and forth of the power. Power corrupts, absolute power corrupts absolutely. In a two-party democracy, that is, a duopoly system, unlike a monopoly, the voter has an alternative option to provide a negative feedback in response to the errors or the excesses of the incumbent party. Consider, for example, on the immense popularity of Franklin Delano Roosevelt in 1936 with the New Deal in full swing, the Democrats won a historic 334 seats, putting the Republicans on the verge of extinction. That was the highest watermark of any party power, and the highest imbalance ever in the history of the U.S. House of Representatives. Yet, in just 2 years, the midterm voter swing delivered a historic loss of 72 seats. Hence, the pendulum swing analogy is not merely for visual imagery, but also suggests a negative feedback mechanism, a force that works against the party in power, and prevents the monopoly of power. The hypothesis of negative force like that of a pendulum, can be checked in a very simple and naive way. Consider the data. The question is, for a given value of the imbalance, say delta p, what is the change delta x that follows? The key idea is to look for a negative correlation, like the negative sign in Hooke's law or gravity lateral force on the mass of the pendulum. The results indeed confirm the hypothesis. The left chart is for the Republican Party, and the right chart is for the Democratic Party. The charts show that the gain or loss in each election is negatively proportional to the number of seats held before the election. In other words, the more seats a party holds, the higher is the expected number of seats that it will lose in an election. Both charts exhibit a negative slope, represented by symbol A hat. The negative slopes are beyond random chance. Shown are the 95% confidence regions, which do not contain value 0. It means the negative slope A hat as shown is statistically significant for both, and has a very low probability to be 0. To apply this consideration to the present time, it is more reasonable to restrict the data to recent demographic generations, say, the last 40 years or so, even at the cost of less data. On the average over the last 40 years, the Republican Party have held 207 seats versus 228 seats for the Democratic Party. Both have the same slope here because the vertical axis is the number of seats gain or loss, which are mirror symmetric between the two parties. Thus, for every 10 seats above the mean 207, the Republican Party is expected to lose 4 seats, and for the Democratic Party, it will lose the same for every 10 seats above its mean, 228. Naive applications of the two considerations discussed above, lead to a projection of net 21 seats gain for the Republican Party, and the same number of loss for the Democratic Party. As a side note, there are more complex statistical approaches how to combine the different factors, but the end result differs from this naive result by only plus or minus 1 seat, hence, it is not worth the time and labor to describe that here. Over 110 years, the Democratic Party has a numerical advantage over the Republican Party in the House of Representatives, as shown in these histograms. There is, on the average, a difference of 43 seats. However, much of that advantage occurred over the long stretch from the post-Great Depression New Deal to the presidency of Jimmy Carter. The U.S. demographics have gone through generational changes as mentioned earlier, hence it is more relevant to consider the more recent data. Here, the Democratic numerical advantage in terms of the mean is only 19 seats. More interesting is the median, as shown, both are practically equal, 217 versus 218. Granted, there are not much data. But there is no known fundamental basis what the distribution should be. In fact, the bimodal nature of the House seat distribution might, or might not have meaning. It could mean that the voters have a preference for the extreme, that is, overwhelmingly support one party at one time, and then support the opposite party at another time. There are many plausible speculations, however, none can be useful for statistical estimation. Given nothing else is known, one can use the naive approach. Here, we already have the empirical probability distribution of the Democratic Party. We also have the distribution of the presidential party, which happens to be also Democratic. Hence, the naive approach is to seek the joint distribution of the Democratic Party by itself, and also the Democratic Party as the presidential party in a midterm. Again, the naive approach is to multiply the two together. In principle, there are data for the joint probability P of A and B. However, over the last 40 years, there were only 4 cases, 2 under Bill Clinton, and 2 under Barack Obama. Incidentally, both have among the biggest midterm losses. To go back even further, there is only one more data, the midterm of Jimmy Carter. Hence, there are not enough data for strict P of A and B, thus, it is a subjective judgment call that we use this approach here instead. Event A, on the left, is combined with event B on the right, giving the combined plot. The joint probability is then obtained. 2 estimates can be used. The mean value, mu, suggests that the Democratic House seats will be 208. The maximum likelihood estimate suggests the value to be 205. The advantage of the joint probability is a narrower range of the distribution, it means higher confidence for the estimates. Combining the factors as shown above gives a new estimate. The Democratic Party will likely have 207 to 210 seats, and the Republican Party will have 224 to 227 seats. There is one more consideration not yet mentioned. It is the statistical behavior of the relative change. For data over 110 years, the relative changes, as expected, display the ubiquitous double-sided Laplace distribution property. It means that the larger the change, the probability for it to happen decreases exponentially. In principle, this probability can be combined with the previous joint probability to re-estimate the expected value. However, when this approach is applied to the last 40 years, there aren't enough data, and there is insignificant change to the result. A reason is that the midterm voter swing distribution already implicitly includes the statistics. Hence, this approach does not produce any new result. The economic factor is thought to be among the most, if not by itself the most influential factor on the voter's behavior. Unquestionably anecdotal, human interest subjective accounts are abound. The challenge is to discern and distill folklores and punditry into rigorous and objective analyses. It turns out the many data points of the midterm election narrative are coincident, and perhaps caused by the economic factor. This part is as long as all the above, and thus should be a separate video by itself. Here is a quick synopsis of the concept and result. Consider a historically most documented case of politics and economy, the Great Depression. Direct testimonies of actual voters at the time supported the narrative that voters in general want changes in a dire economy. The task here is to use classification algorithms to link the economic indicators, shown here are the unemployment rate, the inflation, and the GDP change, to the actual election outcomes. The economic data are available from 1947, and there are many recessions, associated with the rises of the unemployment rate and the drops of the GDP. In addition, inflation, which has been quiet since the 1980s, is coming back in the news in 2022. The question is, given the purported public pain by the economy's situation, what are the most consistent and predictable voters' behavior that is reflected in an election outcome? The idea is straightforward. The economic indicator values, that is, unemployment, inflation, GDP for a slice of time before an election cycle, are taken as a data point. This data point is associated with that election cycle result. The set all of these data point associations forms a training set. The training set is fed into number crunching classifiers. Shown here are 3 types, but the most interesting and consistent results are from the neural network classifier. The trained classifier is then used to predict the outcome of the 2022 midterm election. The following summarizes the main results. The machine learning prediction varies widely versus the way the data are processed. Slice of time from 3 to 12 months have different results. It is not clear-cut what is the best. Coarse discretization of election loss or gain yields more consistent results. In other words, the classifiers are less consistent if the losses are categorized in 5-seat block, compared to larger block like 20 seats. Indeed, the economic factor prediction is best for large loss or gain, but not useful for modest political loss or gain fluctuations. As a result, the neural network outcome should be combined with the statistical estimates shown above. Lastly, there are clear evidence that not all significant election swings are associated with the economy. This is the reason why the economic factor alone, without the data from other social and political factors, is necessary but cannot be sufficient by itself as a predictor of election outcome. For the 2022 midterm, given the inflation, but with relatively strong employment as of now, the classifier only slightly shifts the distribution curve to a small additional loss of the incumbent presidential party. In fact, it appears that the economic factor is already responsible for a number of large midterm swings, and hence, the phenomenological distribution discussed above, in effect, already implicitly includes the historic economic factor. The greatest unknown is, of course, the socio-political factor. Nevertheless, this analysis, based on historical and economic considerations, offers a starting point for the prediction of the election outcome.